Okay, so here you have a little rig. That's a little setup. I want to do a little demonstration of how this air compressor works for the AC system of a car. Now this one is the one that I did the previous video, and I was explaining it was making some irritating noise while the engine was running and the compressor was not engaged. The AC system was not switched on, but it was making an irritating noise. So today I want to show you, demonstrate how this system works. This one here, as I was explaining in the previous video, I was referring to it as a conductor, which is also the magnetic clutch. So behind this conductor or magnetic clutch, we have a coil winding that generates electromagnetic current when the AC system is switched on. So depending on the model of the vehicle or the year of manufacture, we have a switch that switch the compressor clutch relay on, and when that relay gets activated, it transfers power to this switch here. This is the magnetic clutch switch, this one here. So it's that coil winding switch, and this is the connector. The power comes from the battery. If I do a little demonstration, you can see the clutch moving, or the conductor plate, or the magnetic clutch. It is moving, and it has this diaphragm here for flexibility, for making it to be flexible and move with ease. So assume that the engine is running at idle and the AC switch has not been put in the on position, and the engine is running at idle. So like that. Now the belt is running, and if I switch it on, it connects the pulley. So that electromagnetic current or electromagnetic field that is generated in this coil winding, it pulls this clutch or the conductor inwards towards the compressor, and this pulley gets engaged. It gets clasped, and now that is the point that the compressor is activated, and it starts pumping the AC gas or refrigerant into the AC system. So if I repeat it again, I'm rotating this pulley, and then I connect the power, and the pulley gets clasped by that electromagnetic current that pulls this clutch or the conductor inwards, and that one, it clasps this pulley firmly in position. So when the pulley rotates, the whole compressor is working now. Now when the AC system is working, this compressor has been turned on. A lot of load and stress is put on the engine, and that's why on some vehicle, the air conditioning control module, it communicates to the PCM or the computer control module and tells it that the compressor has been activated. So the PCM adjusts or increases the pulse width of injectors to keep the engine from shutting down, because that load is quite heavy on the compressor. And that is when most engines are under heavy load, when the compressor is switched on. That's why some people say that when you switch the AC on, a lot of fuel gets consumed. It is solely because of that reason. The injector pulse width is increased, and a lot of fuel is injected into the engine, and in that way fuel consumption slightly goes up to keep the engine from shutting down because of that load on the engine. Now the reason why the load is quite heavy on the engine, because there's some resistance when this belt is rotating and this compressor gets activated. We have a load because the compressor is filled with refrigerant, and pushing that refrigerant is like we have an opposing pressure, so we have a load.